Given question, 4-cylinder 4-stroke engine develops power of 180 kilowatt at 1500 rpm. The brake specific fuel consumption is 0.19 kilogram per kilowatt hour. At the beginning of injection pressure is 30 bar and the maximum cylinder pressure is 50 bar. The injection is expected to be at 200 bar and maximum pressure at the injector is said to be about 500 bar. Coefficient of velocity of the fuel flow is equal to 0.69. Specific gravity of fuel is 0.875. Atmospheric pressure 1 bar. Effective pressure difference is equal to average pressure difference over the injection period. Crank angle 15 degree. Determine the total orifice area required per injector. Fuel consumption per cylinder. Fuel injected per cycle. Let us understand given data. This is the 4-stroke 4-cylinder engine. Power output capital P is equal to 180 kilowatt. Then speed is given 1500 rpm. For speed, we will use the notation capital N. Brake specific fuel consumption, that is BSFC, is equal to 0.19 kilogram per kilowatt hour. Now in the data, it is given that initial and maximum pressure for this injection and cylinder. So for this initial term or the pressure at the beginning, we will use the suffix 1, and for the maximum pressure, we will use the suffix 2. Now this is initial injection pressure. So we will use the notation P1 and for injection INJ. So it is equal to 30 bar. Initial cylinder pressure. So for initial we will use suffix 1, that is P1, and for cylinder we will use CYL is equal to 50 bar. Now maximum injection pressure. So for the maximum term we will use suffix 2, that is P2, and for injection INJ is equal to 200 bar and maximum cylinder pressure. So for maximum term we will use P2 and for cylinder CYL is equal to 500 bar. Now the coefficient of velocity of the flow of the fuel is given. So its notation is CD. So CD for injector 0.69, specific gravity of fuel 0.875, atmospheric pressure 1 bar, and effective pressure difference. So what is this effective pressure difference? So if we observe the different formulas, then we have the pressure difference, that is pressure at the injector minus pressure in the combustion chamber, that is P injector minus P cylinder. So this pressure difference is known as effective pressure difference. So I will write here the notation for effective pressure difference, P injector, that is PINJ minus PCYL. So this term is used in the calculation. So for this given data, how to calculate this term P injector minus P cylinder? So for that it is given that average pressure difference over the injection period. So this average pressure difference we will calculate with the help of this data, that is the initial pressure and maximum pressure. So from this initial and maximum pressure we have to first calculate the average pressure difference. Then crank angle. So crank angle is known as theta. So theta is equal to 15 degree, and we have to calculate the total orifice area. So this is the question. Now we will first calculate the power output per cylinder. So this is the total power output is given. Number of cylinders is equal to 4. So for the 4 cylinders, 180 kilowatt power output. So for one cylinder, 180 by 4, 45 kilowatt. Then fuel consumption per cylinder. So how to calculate the fuel consumption? That is power multiplied by brake specific fuel consumption. So power is given in kilowatt. So we will first take the units. So BSFC is given in kilogram per kilowatt hour multiplied by kilowatt. So if I take here kilowatt multiplied by kilogram per kilowatt hours. So this kilowatt is getting cancelled. So we will get fuel consumption 45 into 0.19 is equal to 9 kilogram per hour. But if we observe, speed is given in revolution per minute. So this hour we will take into the minute. So how to consider this minute? So in 1 hour there are 60 minutes. So we have to take here 9 divided by 60. So it is kilogram per minute, which is equal to 0.15 kilogram per minute. So we will use this fuel consumption. Then fuel injected per cycle. So fuel injected per cycle, fuel consumption divided by n by 2. So why n by 2? Because this is the 4-stroke engine. So we have to take n by 2. Suppose there is 2-stroke engine, then we have to simply take n. So first we will take fuel consumption divided by n, that is 1500 divided by 2. Now if we observe, for this fuel consumption unit is kilogram per minute. So we will take the units. So fuel consumption is given kilogram per minute, and this 1500 is revolution per minute. So I will take, so it is in the denominator, so it is 1 divided by revolution per minute. So this minute term will move to the numerator. So this minute is getting cancelled, and therefore fuel injected per cycle. So per cycle, that means per revolution. So fuel injected is unit is kilogram. So 2 into 10 raised to minus 4 kilogram. This is the unit. Then time for injection. So time for injection, we have formula theta divided by 360 multiplied by n by 60. Now this n is given in revolution per minute. So we have to take this revolution per second. So we have to divide it by 60, because in 1 minute there are 60 seconds. So we will take here theta, crank angle is given 15 degree. Then this is 360, that is the number of degrees in one cycle, multiplied by 1500 by 60. So answer is 1.6 into 10 raised to minus 3 second. Now why unit is second? Because we have converted here revolution per minute into revolution per second. So this second we have to give the same unit. Now we will calculate average pressure difference. So how to calculate this? So we have to first take the injection pressure difference. So here the pressure, initial injection pressure and maximum injection pressure. So if we take the difference, that is P2 injection minus P1 injection, that is 200 minus 30 is equal to 170 bar. So this is the injection pressure difference. In the same way we will take cylinder pressure difference. So here two pressures are given, initial cylinder pressure and maximum cylinder pressure, that is P2 cylinder minus P1 cylinder. So it is 500 minus 50, it is equal to 450 bar. So this is the pressure difference. Now we have to take the average for this two pressure difference. So how to take the average? That is 170 plus 450 divided by 2. So this is known as average pressure difference, and it is equal to 310 bar. But we know that standard unit is Newton per meter square, that is used in the calculation. So we can convert this 310 into 10 raised to 5 Newton per meter square. Now we will calculate velocity of injection. So for this we have formula. It is CD under root of 2 P injection minus P cylinder divided by density of the fuel, that is rho F. So here notation is used. Now if we observe, specific gravity of the fuel is given. Now from that we can calculate the density of fuel, that is rho F is equal to specific gravity multiplied by 10 raised to 3. So this is the formula. So if we multiply 10 raised to 3, then 875 is the specific gravity. So we will put the values. So CD is 0.69 under root of 2 multiplied by, so P injection minus P cylinder is the average pressure difference, and that is equal to 310 into 10 raised to 5 divided by density of the fuel is 875. So here 875. So when we calculate, we will get the answer 183.6, and the unit is meter per second because this is the velocity. To calculate the total orifice area, we will take the formula for the volume of fuel injected per cycle. So its a formula is nozzle orifice area multiplied by injection velocity multiplied by injection time. Now in earlier we have calculated the injection velocity and injection time, and we have to calculate the nozzle orifice area. So we will first calculate volume of fuel injected per cycle, and we have formula BSFC by 60, that is brake specific fuel consumption. It is given in kilogram per kilowatt hour, but we have to take the unit for time is minute. So we have to divide it by 60 multiplied by the power output. So we have to take the power output per cylinder, that is 180 by 4, that is 45. Then divided by rpm by 2 multiplied by density of the fuel. So why we have to take rpm by 2? Because this is the 4-stroke engine, and for that we have to take rpm by 2. For 2-stroke engine we have to consider only rpm. Now we will first balance the unit. So I will write the unit for BSFC, that is kilogram per kilowatt hour. So I will write here kilogram per kilowatt hour. Now divided by 60. So we can take here kilogram per kilowatt minute. So I will convert this into minute. Multiplied by P. So power output is in kilowatt. So we have to multiply with kilowatt. Divided by rpm by 2. So it is revolution per minute. So I will take revolution per minute multiplied by density of fuel. It is kilogram per meter cube. Kilogram per meter cube. So we have to balance this. So I will simplify all these units. So if we observe, this kilowatt is getting cancelled. Now I will write kilogram per minute. Now this is denominator term. I will write minute per revolution, and here meter cube per kilogram. So if we observe, this minute is getting cancelled, kilogram is also getting cancelled. So remaining unit is meter cube per revolution. So volume is also in meter cube per revolution. So we have to calculate all this data. So if we observe 0.29 by 60 multiplied by 45 divided by 1500 by 2 multiplied by 875. So when we calculate, we will get 3.3 into 10 raised to minus 7 meter cube per revolution. So this is the volume. So volume always in meter cube. Now we will put all this data in the formula. So nozzle orifice area is AF. So AF is equal to this volume divided by injection velocity multiplied by injection time. So volume of fuel injected. So it is 3.3 into 10 raised to minus 7. Then injection velocity 183.6 and injection time 1.6 into 10 raised to minus 3. Now again we will balance the unit. So its a unit is meter cube per revolution divided by. So divided by velocity meter per second, and this duration, that is injection time, is in second. So if we observe, this second is getting cancelled, and this meter cube by meter is meter square. So this No, total orifice area unit is meter square and answer is 1.12 into 10 raised to minus 6 meter square.